So let's talk about why water is a polar molecule and what special properties that leads to. We know that water is H2O, that is one molecule of oxygen and two hydrogens. That if this is a molecule made with covalent bonds, where electrons are shared between these atoms, thereby giving them full valence shells each. That we know that this molecule is polar. What this means is that these electrons in this covalent bond are not shared equally. Oxygen's higher electronegativity pulls these electrons towards it, giving it a slight negative charge, and the hydrogens a slight positive charge. That if we consider, this is a diagram showing electron density, that the electrons spend about 10 times more time around the oxygen than they do the hydrogen. As a result of this property of having partial charges, of being polar, water has a number of special properties that if we have two water molecules brought close together, in this diagram we see one water molecule that the partial charges are denoted by different colors, the oxygen having a slight negative and the hydrogen a slight positive. Another water molecule that comes close by will be attracted to it. This attraction between the partial negative on the oxygen in one water molecule and the partial positive in the hydrogen of another water molecule is referred to as a hydrogen bond, so called because at least one hydrogen is involved in this attraction of opposite charges in different molecules. That this property, that water molecules or any two molecules of the same type stick together, is referred to as cohesion. That as a result of cohesion, you get, for example, the coherence of water molecules in a droplet, that when a water droplet does fall, it does not separate as other liquids might, that display less cohesion as well. That certain organisms rely on the surface tension of water due to cohesion between water molecules, that these water molecules don't separate, and these ants, for example, can form rafts of organisms that can float downriver and resist sinking. When we consider a polar molecule like water and a different polar molecule like ammonia, and using nitrogen with its electronegativity of 3.0 and hydrogen with its electronegativity 2.1, the electrons pulled towards nitrogen, giving it a slight negative charge, and the hydrogen a slight positive. That the opposite charges in these different molecules attract. The attraction of water to other polar molecules is referred to as adhesion. That as a result of adhesion, you get, for example, water molecules sticking to other hydrophilic things, other hydrophilic molecules or materials that happen to have either partial charges or full charges. That what we see here in this meniscus, in this measuring cylinder, is the adhesion of water molecules to the glass that this structure is made of, and as a result they're crawling up the sides, creating this characteristic dip in these measuring cylinders. Adhesion also allows organisms like plants to absorb water successfully, that these plants are perforated, or they're lined with a variety of thin hydrophilic tubes where water sticks to the walls of these tubes by the attraction of opposite charges. This adhesion between water and the walls of this tube actually draws water out of the plant as these water molecules continue sticking to the sides of these thin water transport vessels. As a result of both cohesion and adhesion, we have this particular property, that over time what we see is this: the drop gets bigger because as water molecules flow down the leaf, they cohere through the property of cohesion. This drop increases in size and it sticks to the leaf because of opposite charges in different molecules, in this case the water and the leaf attracting. There are two separate properties involved here, both cohesion and adhesion. We can recognize the difference using our handy diagram, that cohesion is due to the attraction of similar molecules, adhesion between water and a polar surface. In addition, water has a number of other properties that come about as a result of cohesion and adhesion. We may be familiar with some of these, like capillary action, where water is drawn up a thin hydrophilic tube due to adhesion of water molecules to the walls of this vessel and cohesion between water molecules, creating this long pull of water up a thin tube. As well, water has a high specific heat, which allows for evaporative cooling through sweat that water molecules absorb heat and then evaporate, thereby taking this heat away from you as they do so, thereby leaving you cooler overall. As well, as ice melts, these molecules collapse together as they start jostling about and turn into a liquid. That liquid water is actually more dense because all of these hydrogen bonds in between these molecules have collapsed, thereby these water molecules take up less space than the ice, and as a result ice floats on water, thereby preventing organisms that live in bodies of water from being crushed under ice when it sinks as it forms in winter. And as well, because of its polarity, water attracts charged or polar molecules, molecules with either whole or partial charges in them. And as a result, these molecules dissolve very well in water as water coats them in these hydration shells.